In 1901, a group of Greek sponge divers pulled something out of the sea that modern scientists still can't fully explain. They were salvaging an ancient Roman shipwreck off the island of Antikythera, 2,000 years old, buried under 40 meters of water. Most of what they found was expected: bronze statues, glassware, amphorae full of wine. Normal Roman cargo, but among the wreckage was a single corroded lump of bronze and wood, about the size of a shoebox. Nobody paid much attention to it at first. It sat in the National Museum of Athens for 2 years before anyone bothered to look closely. When they did, what they found inside stopped everyone cold. Gears. Dozens of precisely engineered bronze gears, interlocking with each other, inscribed with Greek text, arranged in a system of extraordinary mechanical complexity. This wasn't a coin or a tool or a piece of jewelry. This was a machine, a working calculating machine, designed to predict the movements of the sun, the moon, all 5 planets known to the ancient world, solar eclipses, and even the 4-year cycle of the Olympic Games. And it was built somewhere around 100 BCE. Let that sink in for a moment. A mechanical computer built over 2,000 years before Charles Babbage designed the first mechanical calculator in the 1820s. A device of such precision that when researchers at University College London scanned it in 2021 using 3D X-ray imaging, they found gears so finely cut that they were accurate to 0.5 millimeter. With bronze tools, by hand. This is the Antikythera mechanism, and it is, without question, the most sophisticated object ever recovered from the ancient world. But here's the thing that should disturb you. It's not alone. We need to talk about a category of historical objects that archaeologists call OOPArts, out-of-place artifacts. These are objects found in geological or archaeological contexts where they have no business being. The term was coined by American naturalist Ivan Sanderson in the 1960s, and it has since become one of the most debated concepts in both mainstream science and alternative history. The Antikythera mechanism is perhaps the most famous and the most rigorously studied, but understanding it properly requires understanding just how impossible it really is. The ancient Greeks had philosophy, they had mathematics, they had astronomy, but conventional history tells us they did not have precision mechanical engineering, the kind of fine metalworking required to cut gears at that tolerance level that supposedly didn't exist for another 15 centuries. So how did this device get made? Modern researchers have been trying to reverse engineer it for over 100 years. The work of physicist Derek J. DeSolla Price in the 1970s produced the first serious analysis, but even he admitted that the mechanism represented a level of technical sophistication that seemed to appear out of nowhere, with no clear predecessor and no clear successor, because that's the part people miss. It's not just that the mechanism is advanced. It's that nothing like it appears again in the historical record for over 1,000 years. The Roman Empire came and went. The Byzantine Empire rose and fell. The Islamic Golden Age produced incredible advances in mathematics and optics. And yet, not a single object of comparable mechanical complexity appears anywhere in the archaeological record until the European clock-making tradition of the 13th and 14th centuries. One object, sitting alone in history, like a single footprint in fresh snow with no trail behind it and no trail ahead. Where did the knowledge come from? Where did it go? Researchers have proposed that the mechanism was built by, or at least inspired by, the great astronomer Hipparchus of Nicaea, who lived around 190 to 120 BCE. Hipparchus was famous for his incredibly precise observations of the moon's motion, and several of the mechanism's astronomical cycles match his calculations almost exactly. But Hipparchus left no description of any such device. No ancient source mentions seeing a machine like this. It doesn't appear in Cicero or Pliny or any of the Roman writers who described the wonders of the Greek world. It was simply there, in a shipwreck, waiting to be found 2,000 years later. The 2021 UCL study concluded that the mechanism was so sophisticated it would have required a tradition of similar instruments behind it, a body of craftsmen, a workshop, an ongoing technical culture. You don't build something this complex without years of smaller, simpler devices leading up to it, which means that somewhere out there, buried under the sea or rotted to dust underground, is an entire lost history of ancient mechanical engineering that we haven't found yet. Now let's travel about 3,000 kilometers east. Baghdad, 1936. A German archaeologist named Wilhelm Koenig is cataloging objects from a site near the ancient village of Kujut Rabu, southeast of Baghdad. The site dates to the Parthian Empire, roughly 250 BCE to 224 CE. Among the objects he finds is something that looks, on the surface, completely unremarkable. A clay jar about 14 centimeters tall. Inside the jar, there's a copper cylinder. Inside the copper cylinder, there's an iron rod. The whole assembly is sealed at the top with asphalt. Koenig publishes a paper in 1940. His conclusion is extraordinary. This, he argues, is an ancient electric battery. The design is almost identical to a simple galvanic cell. Fill the clay jar with an acidic liquid, vinegar, lemon juice, wine, and you would generate a measurable electric current between the copper and iron, approximately 1.1 to 2 volts. In the 1940s, American engineer Willard Gray actually built a replica and filled it with grape juice. It produced half a volt of electricity. This is the Baghdad battery, or rather the Baghdad batteries, because Koenig found not one, but several of these objects. Multiple jars, all with the same design, all found in the same site, scattered across a roughly 2,000-year-old settlement. Now, here's where the story gets complicated, because the mainstream archaeological response to Koenig's theory was not enthusiasm. It was polite, persistent rejection. The argument goes like this. We have no ancient source, not Greek, not Parthian, not Roman, that describes electrical phenomena. We have no ancient source that describes using electricity for any purpose. We have no other electrical device found anywhere from this period. No wire, no lamp, no electrode, nothing that would suggest a civilization that understood and used electrical current. And the jars may simply have been storage vessels for scrolls, organic compounds, or sacred objects. The copper and iron may be coincidental. This is a fair argument. It's the correct scientific position. Absence of corroborating evidence is a serious problem. But here is what the skeptics often don't say out loud. The Baghdad battery is not the only ancient object that hints at knowledge of electrochemistry. In 1999, researchers analyzing ancient Egyptian artifacts discovered traces of gold electroplating on objects dating back over 4,000 years. Gold electroplating, the process of using an electrical current to deposit a thin layer of gold onto a base metal, is, by every conventional account, a process invented in the 19th century. The traces were faint. The evidence was disputed, but it was there. You can choose to believe both things are coincidental. That is entirely reasonable. But at some point, coincidences accumulate. and they start to look less like random noise and more like a pattern we don't yet understand. In 1938, a German archaeologist named Chipute was surveying a series of caves in the Bayan-Karaula mountain range on the border between China and Tibet. What he found inside those caves has been generating controversy ever since. On the floor of the caves were dozens of small, delicate skeletal remains, humanoid, but with disproportionately large skulls and very slender bodies. The locals called them the Drapa, and carved into the walls were images of the sun, moon, and stars, connected by lines to depictions of what appeared to be small, thin figures. But the strangest discovery wasn't the bones or the carvings. It was the stones. Scattered across the cave floors were 716 stone discs, each about 30 centimeters in diameter, with a hole in the center, exactly like a vinyl record. And running from the center hole to the outer edge of each disc was a continuous double groove, spiraling outward. Under a microscope, the grooves appeared to be covered in tiny, impossibly precise hieroglyphic-style engravings. In 1962, a professor at Beijing University named Dr. Tsum Nue claimed to have partially decoded the symbols. His translation told a remarkable story. The discs were a record left by a space traveler whose ship had crashed in these mountains 12,000 years ago. The crew could not repair their craft and eventually integrated with the local population. The Chinese Academy of Sciences reportedly refused to publish his findings. He eventually published them in Japan, and the story was picked up by a German journalist named Reinhard Wegemann in 1962. And from there, it entered the global circulation of alternative history. Now, let's be honest about what we actually know here. The Drapa stones have never been independently verified. The original stones were reportedly held at Beijing University, then transferred to a museum, and then their location became unclear. Western researchers who tried to study them were denied access. And crucially, no Western scientist with credible credentials has ever personally examined them. What we have is a chain of secondhand reports, each one building on the last, each one adding new details that weren't in the original account. This matters, because when you strip away the layers of retelling, you are left with a very thin evidentiary core. A reported discovery by a German archaeologist in 1938, a reported translation by a Chinese academic in 1962, and then silence from the scientific establishment, which critics interpret either as suppression or as the absence of anything worth studying. The hard truth is this: the Drapa stones may be one of the most elaborately constructed hoaxes in the history of alternative archaeology, or they may be real objects that were cataloged, misfiled, and lost in the chaos of 20th century Chinese institutional history. Without the stones themselves, we cannot know. But here is the uncomfortable question the Drapa story forces us to confront. How much of ancient history simply hasn't survived? How many objects were discovered, cataloged in private collections, destroyed in wars, or buried in institutional storage, waiting for someone to find them again? Our picture of the ancient world is built entirely from what survived. And what survived is a tiny, arbitrary fraction of what once existed. In 1924, a British explorer named F.A. Mitchell Hedges was excavating the ruins of the ancient Mayan city of Luba-Antun in what is now Belize. His adopted daughter, Anna, who was 17 years old, claimed to have found something extraordinary buried beneath a collapsed altar. A human skull, life-sized, carved from a single block of pure rock crystal quartz. The Mitchell Hedges skull as it came to be known, is one of the most studied and most contested objects in the world of alternative archaeology. When Hewlett-Packard's Crystal Lab, yes, the same Hewlett-Packard that makes printers, examined the skull in 1970, the results were remarkable. The skull was carved with no regard for the natural crystal axis of the quartz. Any modern lapidary will tell you that is insane. When you carve quartz, you work with the axis, because cutting against it risks shattering the entire stone. Whoever carved this skull either didn't know that or didn't care, because they had a method of carving that made the crystal axis irrelevant. The HP researchers also found no microscopic scratches on the surface that would indicate the use of metal tools. Quartz has a hardness of 7 on the Mohs scale. To carve it without metal tools, you would need either harder stone, like corundum or diamond, or an incredibly labor-intensive process of abrasion with sand and water. HP's estimate: if you tried to replicate this skull using the most advanced diamond tip tools available in 1970, working 24 hours a day without stopping, it would take approximately 300 years to complete. 300 years for one object. This is the point where mainstream archaeologists and alternative historians diverge most sharply. The archaeological establishment's response has been that the skull was probably not found at Lubantun at all, that Mitchell Hedges likely purchased it at auction in London in 1943, and that it was most probably carved in Europe, not in ancient Mesoamerica, sometime in the 18th or 19th century. In 2008, the Smithsonian Institution's National Museum of Natural History and the British Museum both tested crystal skulls from their collections. Not the Mitchell Hedges skull specifically, but similar objects, using electron microscopy and X-ray crystallography. They concluded that the skulls in their collections showed evidence of modern rotary carving tools and were almost certainly made in the 19th century, likely in Germany. The Mitchell Hedges skull has never been subjected to the same analysis. Anna Mitchell Hedges kept it until her death in 2007. She never allowed destructive testing, and so it remains exactly what it has always been: an object of extraordinary craftsmanship, uncertain provenance, and unresolved mystery. But ask yourself this: even if the skull was carved in 19th century Germany, the question of how it was made doesn't simply disappear. HP's analysis was done by crystal engineers who knew their field. The absence of tool marks and the disregard for the crystal axis remain unexplained. Sometimes the mystery doesn't belong to who made it or when. Sometimes it belongs to how. In 1929, a German theologian named Gustav Deismann was cataloging documents in the library of the Topkapi Palace in Istanbul. In a pile of old maps and charts, he found something extraordinary: a map drawn on gazelle skin, dated by its own inscription to 1513. The cartographer's name was Piri Reis, a Turkish admiral and cartographer of the Ottoman Empire. The map is remarkable for several reasons. It shows the coastlines of Europe, North Africa, and South America with impressive accuracy for its time. Columbus had only reached the New World 20 years earlier, and most contemporary European maps of the period were rough approximations at best. But one feature of the Piri Reis map has generated decades of controversy. At the bottom of the map, there is a landmass, a detailed, reasonably accurate depiction of a coastline. The coastline, some researchers argue, matches the subglacial coastline of Antarctica. The reason this matters: Antarctica was not officially discovered until 1820, and its subglacial coastline, the actual shape of the continent beneath the ice, was not mapped until the seismic surveys of the International Geophysical Year in 1958. If the map accurately depicts Antarctica's coastline as it would look without ice, that means whoever created the source maps that Piri Rice compiled. He says in his own notes that he drew from multiple earlier sources, some going back to ancient times, had knowledge of a continent that has been covered in ice for at least 6,000 years. How is that possible? The mainstream response is that it probably isn't Antarctica at all. The southern landmass on the map may be a speculative Terra Australis, the hypothetical southern continent that European cartographers included on maps for centuries based on the philosophical argument that there must be a large southern landmass to balance the northern continents. It was a common feature of Renaissance cartography with no observational basis whatsoever, and the resemblance to Antarctica's subglacial coast may simply be coincidence. A coincidence strengthened by motivated reasoning, where people who want to see Antarctica see it because they're looking for it. This is also a fair argument. But Professor Charles Hapgood of Keene State College spent years analyzing the Piri Reis map and other ancient cartographic anomalies. His 1966 book, Maps of the Ancient Sea Kings, argued that the map's mathematical projections were far more sophisticated than anything in use in the early 16th century, and that Piri Reis must have been copying from sources of genuinely ancient origin. Hapgood sent his analysis to the Cartographic Department of the United States Air Force. Colonel Harold Ohlmeyer responded with a letter confirming that the accuracy of the map's southern landmass was, quote, remarkably close to seismic profile data obtained from polar surveys. That letter is real. It exists. You can find it in Hapgood's book. It doesn't prove anything, but it exists. So what do we do with all of this? The Antikythera mechanism, the Baghdad battery, the drop of stones, the crystal skull, the Piri Reis map, 5 objects, 5 separate mysteries, 5 separate chains of evidence that lead in different ways to the same uncomfortable frontier, the edge of what we know. Let's be honest about the state of the debate. First, the skeptics are right about the methodology. Almost none of these objects were found under controlled archaeological conditions. The Baghdad battery was identified from a museum shelf and not from a documented excavation. The Drelpa stones were reportedly found by a German researcher in 1938 and have not been independently examined since. Anna Mitchell Hedges never allowed the crystal skull to be properly tested. The Piri Reis map exists, but interpreting it requires significant assumptions. In science, provenance is everything. A result without a chain of custody is not a result. It's a story. And human beings are the most story-hungry creatures on the planet. We impose narrative on ambiguity with almost involuntary speed. We see a face in a cloud, a message in a map, a lost civilization in a handful of gears. The second problem is selection bias. The 5 mysteries in this video are famous because they are unexplained. But there are thousands of ancient objects that were mysterious for years and then solved by careful research. Nobody makes a 20-minute YouTube video about those. There are no algorithms rewarding the headline, "Ancient Object Found." Completely boring, exactly as expected. The inexplicable gets amplified. The explained disappears. This creates a false impression of frequency. It makes it seem as though impossible artifacts are everywhere, that history is riddled with anomalies, that the official account is constantly under siege. In reality, mainstream archaeology solves far more mysteries than it leaves open. The ones it leaves open become famous precisely because they're exceptional. Third, and this is where it gets genuinely interesting, the skeptics' strongest arguments are also, paradoxically, incomplete. Consider the Antikythera mechanism. The mainstream story now accepts that it's exactly what it appears to be, a sophisticated mechanical computer built in ancient Greece. There is no longer any serious debate about that. The only remaining question is how such an advanced instrument could exist with apparently no tradition behind it and no successors after it. And the mainstream answer, that this is simply a gap in the archaeological record, is technically correct and genuinely unsatisfying, because it's not one gap. It's a pattern of gaps. Roman concrete, which is stronger after 2,000 years in seawater than the day it was poured, and which we only recently reverse engineered after decades of research. Damascus steel, which could bend without breaking and hold an edge that modern steel cannot replicate, and whose manufacturing process was lost when the trade routes that supplied it collapsed in the 18th century. The Egyptian blue pigment, which is simultaneously the world's first synthetic material and a nanomaterial